Okay, so we were on question number 10. We were finding the angle at the beginning. So it says it's perfectly banked for 60 kilometers per hour. So that means leave friction out and solve for the angle. Fny is Fn cos theta. Take your mg over to the other side. So your Fn is going to be equal to mg over cos theta. And then you're going to use this in the x direction. So sum of the forces in the x direction will equal to mv squared over r. And if there's no friction, then this will be Fnx is equal to mv squared over r. So Fn sine theta is equal to mv squared over r. And so then where the Fn is, fill in your mg over cos theta. Times sine theta is equal to mv squared over r. The m's cancel. Sine over cos becomes tan. Take the g down. So tan theta is equal to v squared over gr. So tan theta is equal to 16.6 repeating meters per second squared over 9.81 meters per second squared times 70 meters. Don't forget to square it. Do the inverse tan. 22.024 degrees. 2387, so we'll say 4. Now we want to find the coefficient of friction. So we want to go 90 kilometers per hour. And to do that, you need friction to help you. So friction will be here. This will be F friction in the x, and this will be friction in the y. And you have to redo your sum of the forces in the y direction because there's a y component of friction. And so we still have the Fny going up, we still have the Fg going down, and now we also have friction in the y going down, still not moving in the y. Fny is still Fn cos theta, just like it was in the other part. This is still mg, and looking at friction in the y, it's the opposite side, so it's going to be FFR sine theta. You want to solve for Fn, but remember friction has an Fn inside of it. So this is really Fn cos theta. Mg doesn't have an Fn inside of it, so we're going to take this over. Minus mu Fn sine theta is equal to mg. And now pull the Fn out. So cos theta minus mu sine theta. And then divide each side by the bracket. So Fn is equal to mg over cos theta minus mu sine theta. So just like we always want, we have an expression for our Fn in the y direction. So now we can go to the x direction. So in the x direction, sum of the forces equals max. And there are two. There's the F friction in the x and the Fn in the x. They're both going towards the center, so they're both positive. So Fnx plus friction in the x equals m, and ax, remember, is v squared over r. So Fn, and the n is the opposite side, so it's going to be Fn sine theta plus friction in the x is the adjacent side, so plus FFR cos theta is equal to mv squared over r. So really this is Fn sine theta plus mu Fn cos theta equals mv squared over r. So we're going to sub in for Fn, but you don't really want to sub in both spots. It's going to make life complicated. So instead, pull the Fn out and have Fn bracket sine theta plus mu cos theta equals mv squared over r, and now sub in just in the one place to make your math life easier. It'll work the other way, it'll just be more complicated. So mg brackets sine theta plus mu cos theta. That's from the top, the mg is from your Fn, and the bottom part's from your Fn. cos theta minus mu sine theta. And this side doesn't change. So now your m's will cancel. And you were solving for mu and it's stuck inside both brackets, so cross multiply. So it'll become gr brackets sine theta plus mu cos theta. So you've brought the r up. And now take the bracket on the bottom to the other side, cos theta minus mu sine theta. Now multiply through to get the mu's out of the brackets. So gr sine theta plus mu gr cos theta is equal to v squared cos theta minus mu v squared sine theta. Now take your two terms with mu to the same side and the two terms without mu to the opposite side. So I'd bring this over and I'd take this over. So it'll be mu gr cos theta. And then when I bring this over, it becomes plus mu v squared sine theta equals v squared cos theta. And when I bring this first term over, minus gr sine theta. Now factor out the mu. So mu brackets gr cos theta plus v squared sine theta. And the other side doesn't change. And then divide by this bracket. And I'm just going to move up here. Oops, except it'd be handy if I could see. So it'll be mu equals v squared cos theta minus gr sine theta divided by gr cos theta plus v squared sine theta. And now fill in your numbers. V this time is the 25 meters per second. So 25 meters per second squared. Cos of the angle we had just found, 22.024 minus 9.81 meters per second squared. The radius was 70 meters times the sine of 22.024 divided by 9.81 meters per second squared, 70 meters, cos of 22.024 plus 25 meters per second squared, sine of 22.024. Carefully type this into your calculator, and when you do, you should get 321.885 meters squared per second squared on the top. I'm just writing this down so if you can't win with your calculator, you at least maybe figure out which part that's not right. And on the bottom, 870.96 meters squared per second squared. The units cancel, and you get 0.3696 if you and your calculator are friends. Okay? So that was number 10. Hopefully it's okay now.